Hey guys, I'm sick. I'm sorry. Um, my stress level got to me and I became susceptible and weak, susceptible to germs. So I got sick. I got a cold. And now I sound really weird. But we're going to move on anyway. So, lesson 6.4. So, you guys take care of yourself. Make sure you take care of yourself, or else you're going to end up like this. The quotient rule. Okay, quotient rule means a division rule because we did the product rule last time and that meant a multiplication rule. Okay, now, before I get into the quotient rule, I'm going to go over, you know what, actually, I don't really want to go over it. This is going to be a very slow motion proof of the product rule. It's all right here. You can read it on your own if you want to, and write it down if you wish. Okay, so I'll slide through it very slowly so that you can pause. I know it's a huge process, and there are university courses that literally just go over proofs. Like that is the course. The entire course is just to go over math proofs. And that might sound fun for some of you guys, but I don't think that'd be very fun. Actually, I took the course, so I can tell you right now it wasn't very fun. All right, so product rule right now is if you have two functions that are multiplying each other like v and u, product rule is going to be if you take one of them, don't do anything to it, it's going to be multiplied by the derivative of the other plus that second function multiplied by the derivative of the first. And it doesn't matter what order you do this in because they're adding each other. So, I mean, like you could swap the orders, it really doesn't matter. But if you take a look at the quotient rule, there is a subtraction right here. And because there's a subtraction, it does matter which order you put things in because if you obviously swap them, you're going to get a different answer. Okay, so this one takes a little bit of memorization on your part. Now, what is all of this? Okay, so f at x is equal to this function. And we have a numerator function, okay, and then a denominator function. I say denominator weird now. Okay, so the way that we do the quotient rule is you have g at x first, don't touch it. Okay, you're going to multiply that by the derivative of the numerator, subtract the normal numerator multiplied by the derivative of the denominator. Okay, and that's all going to be over the denominator function squared. In other words, on the right-hand side, f prime at x is equal to gh prime minus hg prime all over g squared. All right, now I want to mention something really quickly before I get into this. You don't have to memorize all of these different equations because there is a quotient rule and there's a product rule. But I myself hate memorizing this quotient rule. And so I almost always memorize just the product rule because you can't mess up the product rule. It's an addition rule, right? But this one you can mess up because, you know, it's a subtraction. So the way that I get about it is if f at x is equal to h over g, why don't I just rewrite it as h multiplied, so product rule, g, and you're like, well, no, we can't. We divided g, right? But I'm going to have it with an exponent -1. So -1 made it so that it was in the denominator in the first place, right? If I rewrite it so that h at x and g at x are side by side multiplying each other, I can use the product rule instead. And then I don't have to memorize that quotient rule. However, doing g at x to the power of -1 requires something called the chain rule. And that's something that I'm going to be teaching in, I think, not the next video, but maybe the next video. One of those videos. Okay, so for this video, I'll show you how to do the quotient rule just in case you like the quotient rule. Okay, so I'm going to scroll down, but I want you guys to still be able to see the quotient rule, and let's try it out. So example number 1, they're telling us to take the derivative of this giant function. Okay, and what we're going to do is we're going to start off with separating h at x and g at x. So I have my blue function and my green function. If you want to, you can always do the derivatives on the side instead of within the work. I myself just do it within the work because I'm very comfortable with it. But if you're not that comfortable with it yet, just do it off to the side. So I think I'm going to show you guys off to the side just because this is a tutorial. Like, we're still new to this. Well, you're still new to this. G at x is equal to x minus 3. All right, so that's your denominator function. Taking the derivative is where I have a 1 up here, right? And I'm going to do the power rule. Bring the 1 down, x to the power of 1 minus 1, which is 0. And then derivative of 3 is just 0, right? So then 1 times x to the power of 0 is just 1, and then the 0 is, I don't even care about that. Okay, so that is the derivative of g. Now let's do the h. So h at x is equal to x squared minus 2x plus 5. So the derivative of that is going to be, do the power rule again, bring the 2 down. So you're going to have 2 to the power of x, and then that 2 exponent is going to subtract 1, which makes it x to the power of 1. And I'm not going to write the 1. Now this has an exponent of 1. I'm going to do the same thing, power rule, negative 2 x to the power of 0, right? And then the 5 is going to become a 0 when we do the exponent because it's a constant. So we have 2x minus 2 times 1, which is just 2. All right, so we have our new g prime at x and h prime at x. Okay, so again, you don't have to do this work on the side if you don't want to. You can always do it within our work here. So it already tells me that they want to take the derivative. So I'm just going to put an equal sign, and what I'm doing right now is the derivative. Now let's follow that red formula at the top. G at x first. So g at x is x minus 3. It's the blue denominator. Multiplied by h prime at x, and that's what I found on the right-hand side in green. Okay, and then subtract h at x, which is our numerator, x squared minus 2x plus 5. All right, and then we're going to multiply g prime at x, which we found right above, which is 1. I'm going to put that all over g at x squared. Okay, so that's this. All right. Now, normally what I would say is as a teacher, I would say just leave it like that so that I can see that you did the derivative correctly. Like when you start to simplify stuff, it's hard for me to see the derivative anymore. However, this question did say to fully simplify, and so that's what we're going to do. We're going to open up the top and see if we can simplify anything, make anything look nice. So why don't we just do FOIL this way? And we're going to get 2x squared minus 2x minus 6x plus 6. Now, 1 times that entire bracket is not really going to matter too much. That negative, though, in front of the green bracket is going to change the symbols of everything inside. Okay, and then all of this is still over x minus 3 squared. Now, I'm not really going to expand the bottom because I am very curious to know what the top looks like first. If the top becomes something that I can factor, I might be able to cancel it out with something on the bottom. So let's just take a look at what happens on the top. You have a 2x squared and an x squared subtracting, so I'm going to get 1x squared. This negative 2x and that positive 2x are going to make a 0x, but I still have a negative 6x. And now that I've used it, the only thing left is the positive 6 and the negative 5, which makes a positive 1. Okay, so I've used up everything, and now I have x minus 3 squared on the bottom. We always want to take a look at the numerator and say, okay, can this actually be factored? Because if it can, and there just happens to be an x minus 3 on the top, it might be able to cancel out with the 2 x minus 3's on the bottom. And I could be like, oh, okay, it looks a little bit nicer now. I can simplify further. However, it actually doesn't look like I can find anything that multiplies to 1 and adds to -6. So I actually don't think the top is factorable at all. That means I'm going to get rid of all this, and that is my final answer for my derivative, okay, using the quotient rule. Remember how I said that you could actually use the product rule as well, but with a -1 exponent? So using the product rule and the chain rule later on, you'll actually see that you could get the exact same answer, but using the product rule instead of using the quotient rule. Okay, so let's try another one. Okay, I'm going to have to extend the page. I'm sorry. That's just how Smartboard works. Okay, so notice this one says find f prime, and they gave us f at x, but don't simplify it. And again, that is a teacher's way of saying, all I want to know is that you've learned the skill of how to actually take the derivative. I'm not testing you on if you know how to expand and simplify and factor. All I want to know is, do you know how to take the derivative of something? And so I can't see that if you do start to simplify. Plus, it actually takes a lot of time. So we don't want you to waste your time that way. We just want to see the derivative. Let's tackle this guy and this guy off to the side first. Okay, so why don't we do g at x again first? I don't know where that came from. Okay, actually, you know what? I can just, I'll just write it here. G at x is equal to 2x squared plus 3x minus 5. So if we take the derivative, and I'm just going to go a little bit faster now because I'm hoping that you guys already understand the power rule pretty good. So taking the derivative, this is going to become 4x to the power of 1. This is a 1. Taking the derivative of that portion using the power rule, it's going to be 3 without an x because the x is to the power of 0. And then that -5 disappears. So that is the derivative of g at x. Now h at x is this huge cubic polynomial, x squared plus 6x minus 3. And so the derivative is going to be, bring the 3 down, so 3x to the power of 2. This is going to multiply the front, -10x to the power of 1. This has a 1 for the exponent, so it's going to be plus 6 x to the power of 0, which means it's just going to be a 1. So let's get rid of it. And that -3, taking the derivative of that, is going to be 0. So this right here is h prime at x. So let's find f prime at x now using the formula. And just going to recall that it's g h prime minus h times g prime all over g squared. You don't have to write that if you don't want to. I'm just writing it for us, okay, so that we have it. All right, 2x squared plus 3x minus 5 is your g. Your h prime is 3x squared minus 10x plus 6. Subtract your h, which is going to be x to the power of 3 minus 5x squared plus 6x minus 3. Okay, and I'm just going to put a little bit right in there. Your g prime is 4x plus 3. And that is all over your g, which is 2x squared plus 3x minus 5 squared. All right, so what we're going to do is we're just going to leave that there because, again, all your teacher wants to see is that you know how to use the formula, you know how to take the derivative. I don't want you to do distributive rule. Can you imagine if you had to do all of this, right? That's going to take forever. Okay, so don't worry about that. Just do the derivative and then we'll look at it. Okay, example number 3. So they give you the function. It looks like some sort of quotient. I'm immediately going to start to break it up. Guys, remember that this one is just x to the power of 1/2, right? So I would still keep that in mind. Anytime that I saw a root, I would immediately change it to a rational exponent. And so they said use quotient rule. Normally, I wouldn't, as a teacher, tell you to use quotient rule. I'd just be like, you should know what to use. And so that's very nice of this question to tell you. But in this case, they do want you to simplify fully. So let's take a look at what this looks like. All right, g at x first. Okay, so that's your g multiplied by your h prime, right? Derivative of the green, minus the green itself multiplied by the derivative of your g, okay? All over g squared. All right, now simplifying that a little bit, you get the next step. You're just going to have to be very careful in terms of your simplifying. Now, I think this might be a little bit complicated. Like, you guys can do these two multiply together pretty well, but this one is going to multiply both, and that's why you get this and you get this. So there's two pieces to it. These guys multiplied together is just going to be a 1. Right now, you're going to continue to simplify it as much as you can. So you're going to scroll down a little bit so that you can see it. And what we can do is we can actually separate like this guy divided by x. And then when I find the answer to this one, which is this guy, I can also divide it by x as well. Okay, so that's why this is down here. So I've separated both of them because this is an x to the power of 1. And I can take, since it's a division, I can take this exponent, subtract the 1 because both of the bases are x. And that means that I have 1x in my answer. Okay, same with this one. If I have an x right here and I also have one at the bottom to the power of 1, I can also interact those two exponents and subtract them because I just want to combine these guys together as 1x. Okay, now that does require you to know a lot about fractions, exponent rules, and so on. I'm not going to explain them in this video because, I mean, this is calculus and vectors now, right? So you should have these skills down pat. And if you don't, just let me know in the comment section. I'll try my best to explain, but you guys know, and some of you guys have commented in the past, it's difficult to explain it through text and much easier through person. So just try your best, and if you have questions, just comment below and I'll try my best to answer them. So don't forget that this is actually our slope. This formula right here, what we just found, is our slope, our overall slope formula for any slopes of any tangents along the original curve. Now what they can say is, why don't you find me an equation of a tangent now? Use your slope, and I want you to find me the equation of a tangent at a specific number. Okay, so what you do is you take your slope, which is the m that you have at the top. Okay, take your slope, use it. Plug in the 4 wherever you see an x, and calculate your slope. Okay, so I got 9 over 16 as my slope. Then since they want the equation of the tangent, we probably should figure out what this point actually is. So right now, all I know is this is 4 and then something. And that means that I'm going to plug it into my original function. Okay, so the function, remember, was, I think it was f at x is 2x minus 1 over root x, right? So that's going to be my blue function, and I'm going to plug in this green 4 into wherever I see an x. And I get a final point. Now that I have my slope and my point, I can then find the equation of the tangent by doing y equals mx plus b, right? So I'm going to plug in my slope right here, plug in my point, here's my y, here's my x, right? X, y. Okay, and solve for my y-intercept, and then finally I get the equation of a tangent line that touches right at x equals 4 on our original crazy quotient function. Okay, that's all I have for you for quotient rule. Nice and short, hopefully. And I'm going to take a break for a little while because I need to get better. Hope you guys have a great day.